Welcome back, viewers. My name is Christian Obodo. In this video, we are going to focus on Surds. Some of these questions we are going to be solving today mostly comes out during job interviews, screening exercise, etc. Pay more attention to understand every bit of it. Again, don't forget to subscribe, like, and share this video, and also turn on the notification bell. Surds. Numbers such as 5, 2 whole number 1 over 3, 0.37, root 49 can be expressed as exact fractions or ratios such as 5 over 1, 7 over 3, 37 over 100, plus or minus 7 over 1. These are called rational numbers. Numbers that cannot be written as ratios are called irrational or non-rational numbers. A very good example is pi, or 22 over 7. Other examples are root 28, root 3, etc. Irrational numbers of this kind is called surds, and that is what we're going to be treating. Let's see some examples. Simplification of surds. We are asked to simplify the following: root 45, root 162, root 3, root 50. We're starting with the first one, root 45. Here, you're going to look for two numbers. When you multiply the two numbers, you get 45. One of it must have perfect square. If you look at it, 9 is a perfect square. So it can also be written this way: square root of 9 will give us 3. So then root 5. Our answer now will be 3 root 5. Then the second one says root 162. The same thing, we're going to look for two numbers. When we multiply the two numbers, that will give us 162. One must have perfect square. So 81 and 2 will give us 162. 81 has a perfect square. So if you look at 6 times 27, we also give us 162. But we can't use this because neither of these is a perfect square. So this can also be written this way. Then square root of 81 will give us 9, then root 2. The final answer is 9 root 2. Then let's see the next one. 3 root 50. So we're also going to do the same thing. Look for two numbers. When you multiply the two numbers, you get 50. One must have perfect square. Don't forget that. So 25 times 2 will give us 50. So then we say 3 into bracket root 25 times root 2. And as you know, square root of 25 is 5. That is what you can see on the board. So then when we did that, we use 3 to open the bracket, and the answer will be 15 root 2. Operations with surds. We're going to start with additions and subtraction. Two or more surds can be added or subtracted from one another if they are like surds, e.g. root m plus root m. That will give us 2 root m. As we know, coefficient of root m is 1. So 1 plus 1 will give us 2. That's how come we got that 2. Then our root m. Let's see some examples. We are given root 12 plus root 27. The second one is root 50 minus root 18. Then we are also given root 60 minus root 375 plus root 135. Then the next one is 2 root 54 plus root 24 minus root 216. So we are starting with the first one. So the same thing, we are going to look for two numbers that will give you 12. One must have perfect square. That's what we did there. The same thing applicable to root 27. As we know, 9 times 3 will give you 27. So when we did that, so we have 2 root 3 plus 3 root 3. Then you can see root 3 and root 3, they are similar. So we can easily add 2 plus 3. That will give you 5 root 3. That's our answer. The next example, we have root 50 minus root 18. We are going to look for two numbers. That is always the key. Out of the two, one must have perfect square. So we can see 25 and 2 will give you 50. 9 and 2 will give you 18. So when we did that, we got 5 root 2 minus 3 root 2. And 5 minus 3 will give you 2, then root 2. The next question. So we'll look for two numbers. One must have perfect square. So for 60, 4 and 15. For 375, 25 and 15. And for 135, 9 and 15. Square root of 4 is 2 root 15 minus square root of 25 is 5 root 15 plus square root of 9 is 3 root 15. So then you can see root 15, they are all similar. So using our board mass, let's bring the positive closer. So then we say 2 root 15 plus 3 root 15 minus 5 root 15. So 2 plus 3 will give us 5 root 15 minus 5 root 15. And when we did 5 root 15 minus 5 root 15, we got 0. Then the next example, 2 root 54 plus root 24 minus root 216. So the same thing, you look for two numbers. When you multiply the two numbers, it will give you 54. Remember, one must have perfect square. You did the same thing for 24 and 216. That is what you can see. So then 2 times root 9 will give us 3 root 6 plus square root of 4, that is 2 root 6. Then square root of 36, that is 6 and root 6. Then we have 6 root 6 plus 2 root 6 minus 6 root 6. So then we do our addition and subtraction. So when we did that, we got 2 root 6. Multiplication, we are given root 27 times root 50. The next one, root 12 times 3 root 60 times root 45. Then let's see the first one. So we're going to look for two numbers. When you multiply the two numbers, that will give you 27. We did the same thing to 50. So 25 times 2, that will give you 50. Square root of 9 is 3, root 3. Square root of 25 is 5, root 2. 3 times 5, 15. Then root 3 times root 2. That will give us root 6. That is our final answer. The next one says root 12 times 3 root 60 times root 45. With these similar things, so the same thing you need to do here, look for two numbers. When you multiply the two numbers, you will get the figure given to you. So we did same thing and we got 2 root 3 times 3 times 2 root 15 then times 3 root 5. When we did our multiplication, so we got what you can see on the board, 2 times 6 times 3. That gives us 36. And root 3 times root 15 times root 5. That will give us root 225. And root 225 has perfect square, which is 15. So 36 times 15, our final answer is 540. The next example, we are given 2 root 5 all square. So what does that mean? So 2 root 5 in two places. So 2 times 2, that will give us 4. Root 5 times root 5, that will give us root 25. And root 25 is equals to 5. 4 times 5 equals to 20. And division. Simplify the following. We are given root 24 over root 50. The next one, root 60 times root 180 over root 75. We're going to take them one after the other. So root 24 over root 50. It can also be written this way, root 24 over 50, as you can see. So let's simplify each of them. So 24, that will give you 4 times 6. Remember, one number must have perfect square. 25 times 2, that will give you 50. That is what we did. So square root of 4 is 2, and square root of 25 is equals to 5. Then 6 over 2 still has root, so we can simplify. So 2 into 6, that will give you 3. Remember, our root is still there, so the answer is 2 over 5 root 3. Then the next example, root 60 times root 180 over root 75. We're going to do the same thing. Let's simplify each of them. So root 60 times root 180, that will give us root 10,800, then over root 75. That is what you can see on the board. It can also be written this way. So then 75 divided by 10,800, that will give us root 144. And square root of 144 is equals to 12. That's our answer. The next one, surd rationalization. Simplify the following. We're given root 5 over root 2. Root 3 plus 1 over root 3 minus 1 over root 27. Let's take them individually. Then root 5 over root 2. So then we're going to rationalize by using root 2 to multiply the numerator and the denominator. Please take note. When we did that, root 5 times root 2, that gave us root 10. Then root 2 times root 2, that gave us root 4. And of course, you know, root 4 has perfect square, which is 2. So our final answer is root 10 over 2. The next example, so we're going to rationalize 1 over root 3 and do also the same thing to 1 over root 27. So let's start. So this one, we don't have issue with root 3, so we can easily just write root 3 over 1. Then when we rationalize 1 over root 3, we got root 3 over 3. Remember how to rationalize? The same thing, when we rationalize 1 over root 27, we got root 3 over 9. Now we can easily find our LCM, which is 9. 1 in 9 will give us 9. 9 times root 3, that will give us 9 root 3, plus 3 in 3, that will give us 3. Then 3 times root 3, that will give us 3 root 3, minus 9 in 9, 1. 1 times root 3, that will give us root 3. So 9 plus root 3, then minus 1, because there is invisible 1 there, which is the coefficient of root 3. So that will give us 11 root 3 over 9, which is our LCM. Now, conjugate of surds. Let's see some example here. We have to simplify 12 root 24 minus root 6. Now we're going to look for the conjugate of root 24 minus root 6. So our conjugate is root 24 plus root 6. The conjugate is just like saying the reverse. Once it's negative in the middle, then the conjugate will be positive. So that's why we have root 24 minus root 6. The conjugate will be root 24 plus root 6. So what we're going to do here now is we're going to use the conjugate to multiply the numerator and the denominator. Remember, the conjugate again is root 24 plus root 6. So we're going to use it to multiply the numerator and the denominator. That is what you can see me doing there. So we use 12 to multiply root 24 plus root 6. That's what you can see on the board there. Then over, we use root 24 minus root 6 to multiply root 24 plus root 6. So we're going to put it in bracket this way so that it will be very easy to expand. So 12 into bracket 4 times root 6 plus root 6. So we're simplifying them. So then for the denominator, we need to expand. That is what I am doing. And that is what you can see on the board. So when we did that, so 12, 4 has perfect square. So square root of 4 is 2. Then root 6 plus root 6. Then over, when we expanded, root 24 times root 24, that will give us 24. Then root 24 times plus root 6, that will give us 12. Then we did the same thing. That is what you can see on the board. Simplification. 12 into bracket, we have invisible 1 there. So 2 plus 1, that will give us 3 root 6. Then over 24 plus 12 minus 12 minus 6. And that gave us 18. So we have 12 times 3, 36 root 6 over 18. And 36 over 18, that will give us 2, then root 6. Thank you for watching.